Hello and welcome to my mini basic course on computer vision. Maybe you recognize this scene from one of the greatest action movies of all times, where a robot from the future is capable to see, is capable to recognize objects, people, and to do what it is supposed to do. In computer vision, we are trying to do exactly that, to teach machines how to see. Our main inspiration are the living systems. We also use algorithms that are not like those that are used in the living systems, but the pinnacle of the present artificial intelligence used in computer vision are convolutional neural networks that are heavily inspired by biological systems. We can use computer vision in many fields. For example, in autonomous vehicles, they need to recognize what kind of obstacles are around them. Which of those obstacles are cars, pedestrians, to recognize what color is on the traffic light and what do the traffic signs say. We use computer vision in industry for quality control, part placement, depalletization, and many other things. We return also to biomedicine because it's producing a great amount of images, and processing them just by humans is increasingly difficult. We can help to visualize some forms of pathologies like COVID or bleeding in the brain and many other things. And also we use computer vision in robotics. The applications of computer vision are pretty much unlimited. Where we can use our eyes, we can think of building a system that will be doing what we are doing. But it exceeds even our capabilities, like for example, by making sharp images out of blurred images, or analyzing data from non-visual systems, like for example from a ground penetrating radar, and many other sources of information that we as humans don't have. The electromagnetic spectrum is basically infinite, and we can see only a small portion of it, which we call the visible light. In computer vision, we are, of course, not limited into processing just this band of the electromagnetic spectrum. We can have multispectral images containing reflections in ultraviolet light, infrared, and many other spectral bands. The problems related to computer vision are several, and one of the main is that we usually do transformation of a 3D space to its 2D representation. By this, of course, we lose quite a lot of data. During this process also noise is added to the data, and we produce great amounts of it. Objects, when we want to recognize them, have some tricky properties, because when we look at them from different points, they look differently, which complicates matters. If we change the illumination, the same object may look completely differently as well. Objects can be occluded, differ in scale or vary in scale. They deform during movements, and background clutter doesn't help as well. But what is the maybe most dominant problem when we try to use computer vision to recognize something, to recognize object, is that objects have the sad tendency to vary quite a lot despite belonging to the same class. We will finish this introduction with a typical computer vision pipeline. So first, we acquire the image. We pre-process it. We do some things with it to make the quality better. We extract features, we do something on a higher level, detect objects or perform segmentation of the image to several parts. And on the high level, we do even more complicated things. Maybe we can try to reconstruct a 3D scene or something even more complex. In the end, this should lead to some decision making. For example, in robotics, the robot will decide what to do based on what it sees.